Hello and welcome to another video about ImmuneExplorer. ImmuneExplorer is a gateway to SEEQ, the Crow Lab's next-gen sequencing database, and a set of bioinformatics tools for BCR and TCR sequences. In this video we're going to be looking at searching for similar sequences in SEEQ and in the PDB. The first thing we'll need to have a look at is how to get from the window that we first see when we launch the program off to that similar search window. On Windows and Linux, you have this menu up at the top of your window. On the Mac, it is very similar, but it will appear instead as a series of drop-down menus up above your database credentials here. So you'll still see search, alignment, diversity, and so on, and you'll still see these same options appearing in those drop-down menus. It just works a little bit better using that alternative method on a Mac. So in order to access the similar search, we need to choose the Search v3j clonotypes, and we will see our new window pop up. If you entered your SSH credentials on the dashboard page, those will be copied back here. But since that's not been done, I'll go ahead and enter my password now. You've got a couple of parameters that you can choose from in addition to specifying the clonotype that you want to search. You've got a selection, a range from 70% all the way up to 100%. I wouldn't go lower than 80, and likewise on the coverage. Of course, the more stringent your controls, the more similar a sequence in SEEQ or the PDB you'll want to go and pull back. So we'll leave it on the default of 80 and 80 for now. And you will next choose your database. Sequence search will search SEEQ, and PDB search will search for sequences reported in the IEDB. And those were curated using a few criteria. We looked at all of the BCR monoclonals reported in IEDB, and they must have paired heavy and light chain information. They must have a PDB number associated with them, and they must not have V germline genes that are open reading frame or provisional genes. And so the first path through the similar sequence search routine is using a single v3j clonotype or a single CDR3. And the way that we would do that is we've got an example here that I happen to know comes from the PDB. You won't get a hit from that in SEEQ, but it's just an example. So we've got selected from our drop-downs here a V gene, a J gene, and a CDR3 amino acid sequence, and we'll press search. And after a little pause, we'll have gone off to our departmental resource and pulled back all of these sequences. And now if I've got the PDB website pulled up, I can just go ahead and search 5FYJ and pull back that structural information. And you can save this entire list as a CSV file, or you can save only those sequences which you've selected. Alright. The alternative options for this would be, of course, to search SEEQ, or if you're choosing a different set of germline genes, you can toggle through the various loci and find that these drop-down menus have been filtered down just so that you can find the gene you're looking for most quickly. Or you can do a CDR3 only search if you're looking at a paper that only provides that information. Just be certain that you are looking at an amino acid sequence with any additional residues truncated off. So for example, if you've got a leading cysteine, you will want to cut that out. That's junctional information rather than strictly the CDR3 that we're going to be looking at. And so if I search on CDR3 only in SEEQ, I don't anticipate that I'll have any matches, but we'll see what happens. Alright, so in fact we do have matches on this CDR3, but since we've got fairly loose identity and coverage criteria, you can see that there are 9 mismatches in here. That's it. So the next path, the alternative paths forward, would be to import a search CSV, and a search CSV would look something like this, where you've got just a V family, a J family, and a CDR3 amino acid sequence. By gene family, we mean, of course, that the allelic distinction is stripped off the end, not that we've just got IGHV2, for example. I know there are some numbering schemes that we'll look at it that way. So if I wanted to go ahead and import that search CSV, we can go ahead and look in here, and we've bundled the program with a sample input for this window, so that you can try it out yourself. And now, again, we're going off to the departmental resource and searching through BLAST databases that have been generated from the data in SEEQ. And so this will very rapidly tell you what sequencing run, what sequencing sample, as well as information about the donor and disease state if that's provided to us. So I'll pause the video here since I don't want to keep you waiting, and we'll resume once we've got those results. Alright, just a minute or two later, and our results have been returned from SEEQ. We can see that we've got, first of all, a Mongo ID, which you can use to either bring to me, or if you're familiar with using the database, you should use that to pull out any information that you're not seeing here that you'd like to know more about. But we can see that we've got, coming from this collection right now, all of your results are going to be coming from the same collection, but in the future, once we figure out the security procedures, you may also be able to search our paired sequencing, if you've been given permission, of course. We've also got the run, sample, donor, and target. The target is not specified here, but if it were, you would be able to see, for example, that this comes from an Ebola donor, and you get some information about how likely that match is and how many matches there are. And you can save this and filter it and process it in all kinds of different ways, and even you can go back and search that pair of V germline, J germline, and CDR3 length to see how many sequences fall within a lineage that your sibling or your similar sequence belongs to. But that's all really open-ended and up to you, and it depends on the kind of project that you're working on. The final path through is just to import a FASTA file, and we've included this sample SEEQs FASTA file here for you to use. That gets sent off to one of our servers and annotated with PyIR, and then from there it's searched through SEEQ in very much the same way as we've been doing. So I can go ahead and pull out that sample SEEQs FASTA file, pull that in. It's being sent off for annotation now, and you can see it's already finished, and we're searching for those sequences in SEEQ now. Alright, I hope this tutorial's been useful. I will try to keep putting out more until we are feature complete with regard to what features are available in ImmuneExplorer. If you have questions that are not covered in these video tutorials, please do reach out to me on email or Slack. I'm happy to help you get started, and I'm excited to hear what projects you are using the program for. Thanks a lot.